There's quite a unique set of circumstances here in northern Alberta, Canada. Something called the oil sands is quite a controversy. Basically, pressure from below is forcing oil to mix with sandy substructure, and then forcing this oil-soaked sand pressured up from below to ooze out into our fresh waterways. This includes lakes, rivers, and streams. But in order to help you understand this just a little bit better, we need to go back to school. And we're going to take a little bit of a geography lesson. You see, in Canada, there's something called the Great Continental Divide. That's the dividing line that runs all the way from Alaska all the way down to South America. It's the highest point in the Rocky Mountains, well above the tree line. This is where all of the water that runs down the west side of that divide goes to the Pacific Ocean, and all the water that runs down the east side goes to the 40 million fine folks out east. That's why you rarely see an eastern gull on the west coast, well, because the west coast gulls are different. Yeah, like that. So, why am I telling you all of this? Well, here's the deal. Canada has over 2 million lakes, and most of those lakes are on the east side of that Great Divide. All rivers flowing east originate in Alberta. 900,000 square kilometers of fresh water is what Canada has. 2018 special reporter for the UN said that 75% of the reserves in Canada have contaminated water. So the health of these waters is of prime importance, as many people rely on the quality of this water. So let's focus on a few of the reasons for this. This is a real problem. There are many of those tar pits around the world, but the largest collection of these are in Alberta, Canada, where close to 25% of the province is affected by it. A Canadian naturalist by the name of John McEwen detailed most of the botanicals in Canada as he made his way across the prairies in 1870 working for the railroads. He spent some time studying the phenomena surrounding the tar sands and made some very unique discoveries. One detail surrounding structure of the oil sands is that water is trapped in the layers of these waterproof materials, which allows the water to become extremely toxic, but can also be flushed out with more water. Basically, what happens is oil pressure from beneath the surface is forced into these sand stratifications and gradually pushes up and oozes out like a tube of caulking. This then pours into rivers, lakes, and streams. When this happens, there are some very toxic mixtures in the form of aromatic hydrocarbons as well as particulate that have some very adverse effect on wildlife. So in 1894, thinking that they could relieve the pressure from below by removing the oil from underneath the tar sands, they used an invention called the Canada rig. That was designed by and constructed by the first person to drill an oil well in North America, James Miller Williams. But they quickly found out that it was much too thick to pump, so the rig could not be used. Incidentally, these Canada rigs were sold to a gentleman by the name of Edwin Drake from Pennsylvania region, where he quickly started the oil boom in the U.S. So for the next 50 years or so, nothing was really done with the tarry substance continuing to ooze into our waterways. But there was a lot of activity worldwide as every chemist was busily trying to find out exactly what this compound was. Every year, scientific journals published more and more details as to the compounds. These tar pits are present in approximately 18 countries, but Alberta's is the largest. Alberta tar sands are the thickest on record, similar to cold molasses. Other tar sands are bitumen mixed with oil, but Alberta's is mixed with oil and fresh water, so the environmental concerns are extremely high if we just leave it. In addition, other things kept cropping up that would overshadow the need to even focus on the oil sands. World War I and Wall Street's collapse in 1929. Canada did fare a little better than U.S. markets overall, but that's the same year that Dr. Carl Clark, working in his laboratory at the University of Alberta, would crack the code for separating large volumes of the tar sands and would help establish the first plant in Fort McMurray. The unique structure of the Alberta tar sands was no longer a mystery. This was a major step forward for the Alberta oil sands, including environmentalism, I might add. We now had a solution to the magnitude of the problem of oily sand pouring into our lakes, rivers, and streams, but more importantly, that it would become financially viable to be able to do that. So Some attempts were made by a couple of companies to make money, but it only produced a couple of hundred barrels a year, so the projects were not viable. But the environmental concerns remained. But yet again, other things stole the manpower away from moving this project forward, but this turned out to be a blessing in disguise because the government suddenly realized just how dependent the country was on foreign oil imports when providing fuel for our troops became a challenge. After the war, the Canadian government started to realize the value of the oil sands and purchased the financially struggling plant in 1949, where extensive research was poured into it. There were other options available as well. Richfield Oil in Los Angeles wanted to detonate a nuclear bomb to apply massive amounts of dry heat to melt the tar sands. One bomb would displace 12 million tons of earth. But being the environmentalists that Canadians are, we chose not to do that. With the fusion, it would turn the oil sands into glass sands because it's 80% sand and 20% oil. So why wouldn't we just leave it alone? Why bother to interfere with Mother Nature? Well, something called alluvial deposits are chunks of oil sands that naturally fall into the waterways that contain heavy oil mixed with sand that produce oil sheen on water. This fresh mountain water suddenly becomes bad tasting and unhealthy for consumption. So physically mining the surface of the oil sands was really the only choice. Stopping natural pollution created jobs as a byproduct. Yay! So the Canadian Oil Sands Company was created, and we finally had options as to the outcome. Dr. Clark's invention created a whole new outlook on the oil sands and what could be done with it. You have to remember that this is a naturally occurring problem that the natives have had to deal with for thousands of years. So processes were improved and the oil sands project finally started to produce substantially and became a global commodity. But a couple of concerns kept cropping up. We were labeled as greedy oil barons and the opposite of environmentalists. There's really no hard definition as to what an environmental worker is. So here's an unbiased perspective of what the oil sands is and isn't, based on what you see and hear in the media. If you take a microscopic view of the oil sands at any single point in time, then it's natural to think that it's a disaster area. You may even disagree, but sometimes the doctor needs to break your bones in order for them to heal properly. Or you need to spend $100,000 to renovate one, $100 with a paint won't cover the damage, and occasionally you need to tear it down and start from scratch. So let's look at both sides of what the suspected crisis of what the oil sands is. It's no secret. Where the evidence is, thousands of kilometers of riverbank reveal a barrage of oil-soaked sand and dead trees. There's no concise reason why thousands of hectares of coniferous and deciduous trees die for no apparent reason. Few people realize what erosion through these layers will do to our water supplies. 20% of Canada's fresh water drains into the Arctic ice field. It's important to note that all of these major rivers that originate in Alberta flow through Alberta oil sand deposits at the bottom of these river basins. The Peace River Basin, the Athabasca River Basin. Each of these rivers flow through the heart of the oil sands. The Beaver River, suspected parts of the Buffalo River Basin, and the outer edges of the North Saskatchewan River. All total, that covers about 75% of the province's watershed. The 13th longest river in the world, the Mackenzie River, the second largest drainage basin in North America, second to the Mississippi. So what do we do to prevent this? What do we do?
Some oil sand deposits are close to the surface and can be mined. A surface mine takes material from one area or strip at a time. Think of an ice cube tray. Topsoil is stored for later use. Then earth layers called overburden are removed and placed in mined-out areas. The ore, in this case oil sand, is removed. All disturbed land will be reclaimed. Soil is replaced, trees planted, and the final mined-out strip can become a lake.
For thousands of years, these rivers were tainted with oily substance falling into the rivers in large clumps. Alberta was forced to try and find ways to clean up this natural oil spill. It may seem that people are ignored in favor of money, but throughout history, the province and Canada have spent endless hours and finances trying to find ways to make the tar sands a commodity instead of a health hazard. Fortunes were lost by several people who thought they had the answer to crack the oil sands, but the only viable way at the time was to mine the gooey substance from the surface. Once removed, it could be replaced with a lush green biome more conducive to nature. You know, there's been quite an uproar about the mines in Fort McMurray. Manipulation by business, political parties, outsiders trying to make themselves look good at the expense of everyday people. People acting out against climate issues and the suspected causes, but do they really have all of the information that they need? Outside of money and jobs, what could possibly be the reasons for defending what the oil sands is all about? Well, thousands of tons of harsh chemicals leaching into our waterways have been prevented. These compositions are now for sale. One benefit of having so many critics is that you're held to a higher standard than most people are. But at what cost?
The hottest summer on record.
Our planet is stressed. The fact that we have apocalyptic-style fires and floods with tornadoes and hurricanes increasing and growing in severity, unlike the world has ever seen, are only telltale signs of an unseen problem. We're calling it global warming, caused by the increase of carbon in our atmosphere, and we're blaming it on a number of things, including the burning of fossil fuels, methane from livestock, and other industry problems. We see the growth of supercell storms more and more in the Category 5 range. We see strange events happening as the Earth creaks and groans around us and beneath us. Loss of life and damage to property are increasing to epic scales as we reel back with new levels of devastation. This is a global situation to which we don't have all the answers. As we know, trees absorb carbon, but diseases caused by insects and excess man-made deforestation are stopping this process significantly. The Brazilian agency INPE reports that 2019 is the highest rate of deforestation since 2008, and that the fires that are happening in Brazil this year are not normal. In North America, we see the catastrophic results of the pine beetle. Healthy pine trees produce a toxin that pine beetles cannot handle. But trees that are sickly stop producing this natural toxin and become susceptible to pine beetle attacks. Something is stressing the trees to cause them to weaken their natural defenses and stop producing this toxin. So we see the increase of catastrophic forest fires and uncontrollable wildfires. But infestations of insects are growing globally. As well, some of the tallest trees in the world, the Douglas fir, are now under attack by their own Douglas fir beetle, and this has been a continual increase since 2015. It's estimated that the pine beetle has killed roughly 55% of British Columbia's merchantable forest. That's about 740 million square meters. So we fully understand that trees collect carbon all of their life. But the important thing to remember is with all of these dying trees, they are now going to release all of that carbon back into the atmosphere. So armed with all of this information, we have to ask the question, is carbon in the atmosphere actually causing global warming? Or is the carbon in the atmosphere simply a warning telling us that we should be paying more attention to something else? Carbon having an adverse effect on weather patterns, seasonal adjustments, and the warming of our atmosphere would seem to be a viable cause. But there's something else that doesn't fit the pattern of the suggested influences from carbon, and we'll look at that next. Everything you have just witnessed is only a collection of symptoms of a much greater problem, one that hasn't been identified, at least until now. Lack of water is creating a world unlike we have ever seen. There's nothing wrong with Mother Nature, as those processes in the form of storms are only trying to reset the damage we've already done. The planet knows that there's too much water in the ocean and is trying to put it back. The biggest source of global warming is the depletion of groundwater. A dehydrated planet will cause the surface to dry out and crack to the point of something called exsiccation, which is the subcutaneous layers below as they lose all of the moisture so vital to keep this planet alive. It starts to collapse on itself and shrink due to a lack of moisture, producing large cracks on the surface and sinkholes. Another term scientists call subsidence, where sections of land many square kilometers in size sink progressively up to a foot each year. The subcutaneous structure beneath dries out and starts to collapse on itself. So how does this happen? As long as history was recorded, there has been talk of people hand-digging wells. Let me repeat that, hand-digging wells. History books tell us that people were digging these wells close to 20 feet or 6 meters deep and finding water. In 2006, I performed some inspections on water quality issues at a well site with several wells and had access to the historical well map data dating back 7 decades. Approximately every 20 years, a new well was drilled because the water quality became unusable, and each progressive well got deeper and deeper to the current 67 meters or 220 feet. The first well at this site was approximately 38 feet. Each previous well was eventually abandoned due to high concentrations of contaminants like iron, sulfur, and hard water deposits from the above layers. It's not uncommon to hear of wells as deep as 300 meters. Thousands of years of abuse have depleted our groundwater, and now we're paying the price. As lakes dry up, trees lose their moisture protection from below, and the soil dries out and releases all of that carbon in the form of gas through the cracked surface right back into the atmosphere. In 2016, I designed and performed a series of laboratory tests and was able to prove moist soil has a much higher efficiency rate of transferring heat than dry soil. Moist soil absorbs heat from the sun and can transfer it to the water table below, whereas dry, exsiccated soil will heat 75% faster than most soil. Okay, we are at the 12-hour mark now. Since the water was added to the tank, light's been on the whole time. The ground surface is quite dry. Of course, it's wet underneath. 65% humidity, 21.7 degrees Celsius. So we'll just leave that there for the day. Once the ground's dry, the next step of this experiment will be to maintain a water level under the soil here at about an inch below the surface. So to use that in a scale factor, that would be 1 inch would equal about 100 feet. Global warming is not the result of carbon. Carbon is the result of exsiccated subcutaneous layers damaged from removal of our water tables. Looking at the continental water table, we have the continent, the ocean, the aquifer. This aquifer is the first line of defense in keeping the pressure from the ocean from infiltrating into our continental structure. When we deplete the groundwater, that line of defense is gone. At that point, we will see ocean water seeping in at lower layers. If left long enough, we will see that the salt water will start infiltrating our water table. This is already happening in India, and the entire country lives off of that aquifer at a commercial level. This is the exact duplicate situation that the Netherlands experienced in the early half of the 20th century when they would use groundwater and then dispose of it, soon experiencing brackish salt seawater seeping into the water table from a kilometer below sea level. The largest aquifer in North America is the Ogallala. Trillions of cubic meters of water have been removed from this aquifer, and it would be foolish for us to assume that all the other aquifers within the continent are not interconnected. Just as well, it would be foolish for us to assume that all of the other continents experiencing the exact same problems as North America are not interconnected in some fashion through subcutaneous channels. According to Delft University in the Netherlands, it takes approximately 150 years to replenish the water table naturally, and it takes about 7 years to restore lakes to their natural water levels. We don't have that much time, so based on all of that information, I have designed a process of replacing that groundwater at a constant, accelerated rate. You can't just dump water into the aquifer to fix it. It has to contain the proper biological structure, so don't damage it any further. The most important pipelines in the future will contain water to help cool the Earth's surface and replenish the continental aquifers. Standard forms of irrigation will help cool a planet, but we are becoming more and more dependent on that because the available moisture content in the soil is missing. We are reducing emissions, but that is only a drop in the bucket compared to the millions of square kilometers of exsiccated soil that is venting carbon. But there is hope. I have spent the last 4 years working on and designing a system of replenishing this groundwater in the most natural way, and in the process have developed module-style components that are almost plug and play. Each complete water plant will not only replenish the soil, but will create employment, provides food sources, will greatly benefit local economies. People ask me all the time, how did you even come up with this? Well, for the past 20 years, it's been part of my job description to go into places like buildings and find out the idiosyncrasies of the building and how people interact with problems within the building and put it into a report format so people can understand that. So when I first heard about carbon being the cause of global warming, the sixth element on the periodic table, that became quite a challenge to me. So I really jumped on that and started doing research, and for 4 years I collected a lot of information and put it into hopefully something that's understandable, that anybody, including a child, can understand what global warming really is. My name is Brian Leslie Sanders. I am the inventor of the Canada House groundwater rehabilitation system. I'm also the president of Studio TV Incorporated and the owner of Stellar Cresco Incorporated. I just want to leave you with this thought. Carbon is in the atmosphere, there's no question about that. But water is the adhesive that keeps carbon in the ground. And when you remove all of that water from the ground, carbon becomes a gas. There's nothing to hold it there any longer. This is a very important issue, and we need to deal with this right away. So I hope you'll take the time to share this video with as many people as possible so we can get this message out. We finally have an understanding of what global warming really is and what we can do about it. So we have steps to move forward. Thank you.